morning, everyone. It's top of the hour, so we're going to go ahead and get started. Thank you for attending our webinar, Listeria Species Fostering a Shift in Food Safety Culture. It's Saturday, and we actually have a fairly decent turnout for being a Saturday. We thank you for joining. We'll definitely try to move these webinars towards during the weekday, but due to some schedule complications, we have it today. All right. Can I just get a reply from everybody in the chat that they can hear me okay? Send out. Everyone hear me okay? All right, very good. Thank you for that. So today your panel is going to be Shawn Gartside from Sample 6 and Trevor Morones from Control Point. Shawn is an industry veteran and he has worked in plants, labs, as well as helped to build them. Myself, from Control Point is based out of Las Vegas, and we are food safety liaisons for the craftsmen and creators of the food and beverage community. Please ask all your questions in the comments, and we'll be sure to answer them periodically throughout this session, and also towards the end, once we wrap up the PowerPoint, we'll have a live Q&A session. Keep your eyes out for the materials that we'll be sending out. There will be PowerPoint as well as the audio. This session is being recorded. All right, today's topics. We'll open up with a quick overview of Listeria species and Listeria monocytogenes, which will help to lay the groundwork to understand why this pathogen is fostering a shift in food safety culture. We'll have a few questions along the way, and then Shawn will take the stage to walk us through technologies, the cost, the benefits, what a return on investment will look like, and covering the benefit of testing in-house versus third-party, or sometimes even both. Listeria. It's said that this microorganism would have been isolated prior to 1924, but the earliest documented isolation was in 1924. And I believe it was in particular to rabbits. That hasn't been confirmed, but this is based on the research that we've done. And it couldn't, this particular species couldn't assign pathogenic microorganism to any bacteria genus known at the time. It wasn't until 1940 that British pioneer for sterile surgery, Joseph Lister, at this point, obviously Listeria is named after Joseph Lister, he named the genus Listeria for catalyst-positive, gram-positive rods. It wasn't until 1949 the epidemic of newborns were affected by Listeria in 1949. And notice that the emergence of Listeria is more so in the last 60 years. So throughout this entire presentation, we'll be talking about Listeria species, as well as LM, or Listeria monocytogenes. So we need to make sure that we have a clear understanding of what we're referring to when we say Listeria. In terms of Listeria monocytogenes, we know that it's gram-positive, catalase-positive, and non-spore forming. There's a beautiful photo here that displays the characteristics: smooth, convex, bluish, translucent. So, outbreaks. Where did we see the first major outbreaks other than in Germany in 1949? Well, in terms of foodborne illnesses, it wasn't until 1981 in coleslaw, an outbreak in Canada, that it really emerged. There's a majority difficulty to find appetizing frontal coleslaw to be displayed in conjunction with negative facts. Listeria monocytogenes was not included in the list of bona fide foodborne pathogens until this Canadian experience. Outbreaks were soon linked to cheese, luncheon meats, chicken nuggets, fish, and presence of food that generally have a mild pH and that are RTE, we find LM. We know that LM grows at values as low as 4.4 pH and can survive values of 4.3. The CDC estimates that there's 1,600 illnesses, 260 deaths annually. The CDC has a great resource of information on their website pertaining to foodborne pathogens. If you get a moment, go over there and check it out if you're looking to do some research yourself. The trend, compared to 1996 to 98, the incidence of listeriosis had declined by about 42% by 2012. That's great. That's a huge impact. However, there was no change in the incidence of listeriosis in 2012 compared to 2006 to 2008. And those numbers are from the CDC website. What else do we know about Listeria? Not Listeria monocytogenes, but Listeria species as itself. Well, it's present in almost everything. It's present in soil. Therefore, a vehicle to get it into our facility could be shoes or clothing, through raw plant and animal tissue. Humans can be carriers as well, But we need to understand where the Listeria can be found in our plants. That will help us determine where we're going to be doing our testing. Floor drains, condensed water, on floors themselves, processing equipment, and surfaces. The most prominent surfaces being stainless steel, glass, and rubber. But Listeria is, it thrives just about anywhere. Now, we're going to be getting into a little bit in terms of culture. Now, we've laid the groundwork for what Listeria species is when we're referring to it in this webinar, what Listeria monocytogenes is, and now how it being such a powerful pathogen is fostering a shift in food safety culture. Now, think of Mr. Gates' quote in terms of food safety. Does it still hold to be true? As we look ahead into the next century, leaders will be those who empower others. In food safety culture, I think we need to, as leaders, empower others to make positive, conscious, courageous decisions to do right, do the best thing. So what are the challenges that we face in the industry? Is it management support, upper management support? Is it tools to deliver the message, or even how to start? Shawn and I were catching up last night, and we were talking about that other than the management support or upper management support, it's the how to start. Where do you begin? The common challenge that each of these will display is receptive employees. If your employees are not receptive to food safety culture, the next challenge will be to find your corrective action to see that the employees are living the food safety culture. But that doesn't really define where we need to start. So let's take a little bit further. Listeria, the pathogen that is fostering a shift in food safety culture because of the power of the pathogen carries. It's targeted to verify the sanitation operating procedures are working effectively. We know that the standards can be worrisome depending on the individual that is assessing those standards. But there's pilots that are being conducted right now in retail outlets by the FSIS, which is obviously a factor that's going to push it even further. And the growing trend for consumers to have ready-to-eat meals, and because of our increasing busy lifestyles, we're going to see that it's pushing Listeria to change food safety culture. Or food safety culture is being pushed to change because of Listeria. We're also seeing health food trends for snacks on the go. Obviously, one of the pathogens that we'll be testing for is Listeria. what do we know about food safety culture? Well, culture in general, knowledge is power, and a strong culture becomes contagious. But even a negative culture can be contagious. When there are less ethics involved, your team is less likely to make conscious ethical decisions. Without ethics, the culture is only a thought. Ethics should be instilled from the beginning. That's where we're going to see that we get the biggest impact. But if we're starting from the middle, we've been in production for a long time, let's just put a number on it for the sake of the argument, 5 years, and we need to change our culture. How are we going to do that? Well, we have to do it together, and in order to do it together, it's going to take an investment of time and money. Well, most of the time, you have to justify the cost of spending that revenue to make those changes. But your ROI, your return on your investment for making those changes, is less turnover. If you have a place, a work environment that's positive, and people see that not only are the managers carrying out what they say they're supposed to carrying out, but they're actually doing it, it invokes that courageous trend to have a positive culture. So ethics are proactive. They're not reactive, much like your food safety plan. Create ethics based on compliance for the entire team to follow. That is a huge topic of discussion. Because ethics are proactive and not reactive, we're setting the stage for what we want. So consider how the message is being displayed, received, and perceived. The food and beverage industry is notoriously known for being diverse. When your diverse team is led by individuals that say what they do and do what they say, you're more likely to receive the results you're set out to achieve. Consider the different types of learners that your team consists of. Myself, I'm a visual learner, but I also like to be able to read it as well. I like to be able to follow up and review it on my own terms and my own time again and again. It's our responsibility as leaders to ensure that we have strong interdepartmental food safety teams that can provide feedback on a regular basis. That's also a big part of food safety culture. You need to have people that are across the entire company organization in order to have the best impact on the food safety culture. So we already discussed from the start, from day one, it's the best way to implement your food safety cultures, and that involves onboarding, uniforms, physical environments such as restrooms, locker rooms, break rooms, and also the management style. This is a little bit repetitive from the previous slide, but these are the things that we should be considering whether we're starting from the beginning or we need to foster a cultural shift. Like I said before, your ROI to invest money in this particular situation would be for less turnover. If you think about the amount of money that it costs to bring an employee on, get them trained, all their paperwork filed, and then them to go through the process, and then the cost of them separating from the company, whether it's on their own terms or your terms, there's a cost associated with that. And when there's less of that, you can focus on other areas. So something that's been in the news, which is another reason why we chose Listeria as such a strong pathogen to fostering a shift in food safety culture, is FSIS is doing a pilot. They're doing a pilot on retailers and whether they're using the recommendations that they've given them for controlling Listeria monocytogenes in delis. So Listeria is pressing on. We're seeing it in the news in the last 2 years more and more. The results of this pilot may invoke change in retailers, which in turn will evoke further change in wholesalers. Do the regulations on state levels, I think it's going to create a better environment for, I'm sorry, not environment, but it's going to create a better relationship between the retailers and wholesalers. But we could see a cost associated with that. In terms of these regulations, generally we see a higher cost of money for testing. So investigators should come in to compare practices observed in retail delis to the FSIS guidelines, and they're looking for product handling, cleaning, sanitizing, equipment controls, and employee practices. It's a year-long nationwide pilot to measure the status of retailers' voluntary adoption of the recommendations. What are some other things that are helping to foster a shift in our food safety culture is the outbreaks, and these are all related to Listeria. As you can see, Jensen Farms being the one that's highlighted here, this was a huge news headline for food producers, for food safety individuals, for many different things. And we won't go into too many details, but just to sum it up, there were the company went out of business. The body, the CB that had done their audit, I believe a week prior, had some negative implications as well. But we see things like this, some negative impacts on our business that are fostering the shift in our food safety culture. So the reactions to the lawsuits from procedures, regulatory authority, consumers, media, the staff, they all play a role in food safety culture. And as we talk about later on, we know that Listeria is a zero tolerance in the United States for Listeria monocytogenes. So I want to briefly touch base on environmental monitoring. Listeria monocytogenes is the only Listeria species that is associated with foodborne illness. However, when the environmental monitoring is conducted, we are interested in finding any type of Listeria, generic Listeria species. If a particular area of the plant environment is supporting one type of Listeria, it could just as easily serve as a reservoir for LM. This is important to understand throughout this webinar because we're referring to Listeria, we're detecting Listeria in our plants to determine if our standard sanitation operating procedures are working correctly. And Shawn will get into some more of this a little bit down the line. But regulators believe that positive tests for LM in finished RTE products is significant evidence that the organism may be a food safety hazard, reasonably likely to occur in the production process for that particular product. Sampling sites and sampling frequency should be considered based on features of the plant and the type of product, the plant layout, and the product flow. All right. All right, and at this moment, Shawn is going to take the mic from here and go into his portion of the webinar. Give us a moment while we switch screens.
So let me know if you guys can hear me.
We can hear you loud and clear, sir.
Okay, and then I will show my screen here. You guys able to see my screen?
You're all good.
Okay. Well, appreciate that, Trevor, and I think that's a really good introduction into Listeria, the history, and why we need to be concerned about it. Like Trevor said, I have worked for a few companies, everywhere from in the lab, doing testing for Listeria and other pathogens, I've also worked with laboratory companies to provide testing for food service companies, big and small, setting up labs. And most recently in my career, probably the last 10 years or so, I've been working with diagnostic companies actually selling into this industry. So many different types of Listeria tests, not only Listeria but other pathogens. But today's focus is definitely Listeria. So I'm very excited and happy and glad that Trevor invited me to join his webinar and go through, and hopefully I can shed some light on maybe some options that you may or may not know you have regarding getting started with Listeria testing, or potentially even making a switch with what you're currently doing. So first I'd like to go through some keywords and concepts with Listeria testing and some things you might hear as you dive into more details with your HACCP plan and how you do this testing. So as Trevor had mentioned, definitely a distinction in how we look at Listeria species versus Listeria monocytogenes. Listeria species, like Trevor said, it contains several species of Listeria. You may hear Listeria innocua, Welshemeri, some fancy names, but the one we're really worried about and the one that is regulated is Listeria mono. Listeria mono is the specific species that was found to be pathogenic that led to those recalls that Trevor had brought up. And because it is pathogenic and we know about that now, there is a zero tolerance that the USDA and FDA have put on this pathogen. So we're looking at Listeria monocytogenes. Salmonella also has that zero tolerance. E. coli 0157 and a few other species of E. coli also have the zero tolerance. Another concept is environmental testing versus product testing. So in the past, most efforts have been really geared towards, do we have Listeria in our product? More recently, the trend has been, and you can see that also in the regulations and the growing concern to have HACCP plans, is to be testing your environment as opposed to product testing, or in supplement to your product testing. So really, the concept here is to be more proactive. So let's look in our environment, take some environmental samples that are less risky if we get positives, but it also lets us understand maybe what's in our plant and what could lead to Listeria getting into our product. And really now product testing is seen as more of reactive. You know, it's definitely higher risk, especially if you do get a positive on product. And hopefully, you know, you have procedures in place if you're doing product testing to hold that product before it gets out into the market. And if you don't, I think that's where we get and we can see some of these recalls, and that's how those happen. Another word is presumptive positive. Now you might hear this as you start getting results or you start looking for results with your Listeria testing. So presumptive positive, as really defined, is any positive by a rapid method. So the USDA, FDA culture method is considered the gold standard. And that gold standard would be considered a confirmed positive. Anything else as you do testing, whether you're doing a PCR, ELISA, or any other type of testing that's not culture, they do consider that result a presumptive positive result. Confirmation, and that's when you actually will grow that presumptive positive and you're able to see Listeria growing on a plate. So those would be considered confirmation results. Again, the gold standard, the USDA has a protocol to culturally confirm products, samples, and FDA has a slightly different protocol for Listeria with a few nuances in there. Not surprised that those two maybe don't have a standard, but they're both good protocols for culturing Listeria. There has been great advancements in technology to identify and detect Listeria in the recent years. So as far as confirmation in this term, it has opened it up a little bit. You are able to call a sample now confirmed if you do use another technology method. So say you're using a PCR and you get a positive, that one would be considered presumptive positive. If you wanted to get a confirmed positive for that sample, again, you could go through culture confirmation, or if you use a different type of technology and got a positive as well, then you could consider that sample confirmed. Most people will, back up here, most people will go through a Listeria species test, get a result, and react on that result as if it were Listeria mono. If they are very curious whether that sample had Listeria monocytogenes, then they would send that in to get confirmed, and they can specifically tell what Listeria species was in that sample. How do you get Listeria on a plate? How do you grow it? And how do you detect it? You'll hear we use enrichment media, and this is really food for the bacteria. Most methods of detection will need to grow up bacteria. They don't grow in size, they really amplify in numbers. So to be able to detect whether Listeria was in that sample, detection methods need to grow those Listeria up to a high level so that their equipment can actually see that. So enrichment media is a way to do that. It has specific nutrients and it gives them a substrate sometimes in which to grow. Some enrichment medias you might hear as you dive into Listeria testing, very typical, is UVM. It's a University of Vermont media. BLEB, buffered Listeria enrichment broths, Fraser broth, MOX. These are all Listeria enrichment medias. Some of them are liquid, some of them are actually solid media on Petri on plates. And then as you start looking at your results and start looking at different technologies, you'll start hearing false positive, false negative, and those are really measurements of the accuracy of a test. Again, as I was bringing up presumptive positive and confirmations, this really goes in line with those two terms. So this would happen if you get a presumptive positive on a test, you go to confirm that positive, and if that confirmation, they're not able to find Listeria there, so it's confirmed negative, then you would consider that first initial screen a false negative result. And this is the practice that the USDA uses, really all very prominent third-party labs use in their processes. So the USDA does a screen, they get a positive by a rapid method, and then they'll go to culturally confirm. Now, if they can't pull a Listeria out of that sample and grow it on a plate, then they would consider that initial presumptive positive as negative, and you would call that a false positive result on that initial test. So moving on, get a little bit more focus on the types of testing methods for Listeria that are out there, commercially available and highly validated. So there's three basic kind of technologies that I'll talk about today. One is PCR. PCR has really come to be a very highly accurate, pretty easy to use technology that is very research oriented. And what companies have done is packaged this research type method for Listeria testing into consumables. They've shrunk it down, and they've really brought this research method into a testing lab and made it easier to use. The target, so really what we're looking at with Listeria, or with Listeria and PCR, is they're looking pretty specifically at the DNA in the bacteria. So the target for a PCR test is internal, so it's inside the bacterial DNA. So they're looking for a very specific fragment, a very specific region in that bacterial DNA that must be there, that's common to all Listeria species, to be able to call it a positive. So their target is really DNA fragment within the bacterial cell. Immunoassay is a pretty broad topic. There's a few technologies out there that use this concept for detection. And when you're talking about an immunoassay, their target is on the cell surface. So its mode of detection is antibodies and antigens, and they're looking for surface characteristics on the cell that match up to the test. So it's more of a lock and key, if you remember that, or if you had that in science, a lock and key relationship where you're looking for antibodies and antigens to identify each other. Some typical immunoassays out there in the market are lateral flows. These are similar to pregnancy tests, basically the same thing, only converted to Listeria testing and other pathogens. ELISA, alpha, these are also technologies that are used within this immunoassay category. Sample 6, this is really our own category. I work for Sample 6, and we have developed a phage-based test. So our target is both internal and external. The phage identifies, a phage is just like a virus. It identifies bacteria and then uses that bacteria to generate a signal on the inside of that bacteria. So it's a little bit different way to go about it. All these technologies are very similar in accuracy, just a different technology to get the same type of result. We want to know if Listeria is in the sample or not. Now, comparing these different technologies and how long it takes to get a result. As I had mentioned before when I was going through the key terms, enrichment media, and that is bacterial growth. So for PCR, you're looking at an 18 to 48 hour growth. So you really need to grow up that Listeria in an incubator in the presence of this enrichment media. Sometimes in some PCR methods, you have to actually do 2 types of enrichment media before you can get a result. So that means you would enrich for 1 day, take the sample out, put a portion of that sample into another different enrichment media, enrich it for another day, so incubate it for another day. Really what you're doing, and the goal of enrichment is to get your target, in this case Listeria, up to a high level, but sometimes that's challenging because there's a lot of other bacteria in there that also want to grow. So they've developed different types of enrichment media to help suppress other bacteria that we don't want in that sample. So PCR, the initial enrichment type period, they're going to grow it for 18 to 24 hours. And depending on the Listeria method you use, or PCR method, it could take 1 to 4 hours after you actually grow up the sample to get a result. And that brings your total time to result, that's what TTR represents, right around 20 to 52 hours, really, again, depending on the Listeria test method you're using. Immunoassay, similar concept. They do need that enrichment or that Listeria growth. Takes a little bit longer upfront for the immunoassay, between 30 and 48 hours. Their detection can take pretty quick. The lateral flows, for example, they can take 10 minutes or less, up to 2 hours in some of the automated immunoassay systems. Bringing total time to result pretty similar to PCR, right around 30 to 50 hours. Sample 6, a little bit different on how we, because our target is a little bit different in our detection, we do not require the growth of Listeria. What we do is we do a 6-hour resuscitation. So it is an incubation, but the goal of the Sample 6 technology is to just resuscitate any Listeria that might be in the sample, make it healthy. A healthy Listeria cell will produce a positive result in our test. And that takes about 5 minutes or so for 10 samples. And that really brings your total turnaround time, time to result, to about 7 hours. Now, detection limits. As I had mentioned, the accuracy is pretty close to the same with these 3 different types of detection technologies. In any test method you choose, you really need to make sure that their claims are 1 CFU, which would be colony forming unit. So 1 Listeria cell. We really need to be able to detect 1 Listeria cell in every sample. And that goes directly to that 0 tolerance. You know, the USDA, FDA regulates Listeria on a 0 tolerance basis, so you can't have any Listeria in there at all. So you really want to make sure that the test method you choose is able to detect within their whole method that 1 cell that could potentially be in that sample.
Don, it looks like we've lost a little bit of your audio. Can you check that for us? Just give Shawn a minute. Go ahead and keep pushing your questions into the chat window, and we'll be sure to answer those. Looks like we have a few that are directed towards Shawn and sample 6. If any of you are going to be in the area in Las Vegas this week, we have a food safety conference that's hosted by the Nevada Food Safety Task Force and the Environmental Health Association at South Point Casino. It's a 3-day conference with a really incredible workshop hosted or funded through a grant from the USDA. So if you're in the area, get in touch with us and we'll get you set up to get you some tickets. Shawn, are you back online?
Yeah, hopefully you can hear me out there. I apologize, not really sure what happened, but seems to have lost my audio. But if you guys can hear me again, then I can just continue.
We're good to go. I can hear you loud and clear.
So I'm guessing that I had gone through and discussed the 1 CFU, so we need to make sure we can detect one Listeria cell per sample. Believe I might have been lost here when I was going through individual test methodology and what the level of Listeria you need to get to after enrichment for those different technologies need to detect. So as I was going through in PCR, during that 18 to 48 hour growth and enrichment, those PCR methods really need to get Listeria up to a pretty high level. So you're needing at least 10,000 colony forming units or 10,000 Listeria cells in every mil. So in every milliliter of liquid in your enrichment media, you need to have a concentration of 10,000 Listeria cells. And that's required based on this PCR method. You need at least that many to be able to increase your chances of detection. Immunoassays, a little bit more. You'll need right around 10 to the 6th, 10 to the 5th, or 10 to the 6th CFU per mil, and that would be post-enrichment. Again, if we are discussing sample 6 does not require an enrichment, which is really an advantage to those plants, that are interested in bringing testing in-house. One thing has been really a stigma put on Listeria testing is growing Listeria up right next to a plant, especially if you have an in-house lab. So one strategy, to get around that is just to not require enrichment. That's what sample 6 has been able to accomplish. And software. Each of these systems typically provide some software to help you analyze the data, make sense, and the software is used. It's a pretty complex system with PCR and some immunoassays and sample 6. It analyzes the data that's generated by the detection systems, and it uses algorithms, however that company has decided to define what a positive is, so that it can produce a pretty objective result. So I guess as you're looking at different methods between objective results, subjective results, there are some immunoassays that require you to really take a look at, for example, the lateral flow. You need to make sure, and to get a result, you're looking for 2 lines. As I mentioned, it's just like very similar to a pregnancy test. So in that case, you're really looking for a faint line that might or might not be there. That's where to have a system with software definitely has an advantage there. So, really as you take a look at the different methods of detection, PCR, immunoassay, sample 6, that kind of brings you to the point, well, now that I know a little bit more about the detection methods, considering should I test in-house, what would be the benefits, maybe the risks, or third-party labs, benefit risks, or maybe you would like to test both. Maybe some of your samples you've been able to figure out test methods that seem to be safe and that you could do easily and simply in the lab, save you money, and really have that flexibility to react. And send out maybe some of the hazardous testing, like the pathogens that require enrichment. Or maybe you just don't test at all. The USDA, FDA, they typically will come out, depending on the size of your plant, and take routine samples on a routine basis, whether that's quarterly or every 6 months or so. And you can rely on them to be taking your samples and providing your testing. So third-party or in-house testing, some things you really need to consider. So when you're considering doing testing or increasing testing, the third-party lab is a good choice. It does keep typically they're very well certified. They have procedures, they have trained technicians, and it's away from your plant. As you consider in-house testing, you really want to make sure, if you're considering that, it's in the plant or near the plant, really for time purposes. And you need to consider your methods carefully if you're testing in-house. Time to results can be a consideration whether you're going to choose a third-party or in-house lab. Because you have to send your samples away, sometimes overnight, that could take an extra day. And then you're at the mercy of the third-party lab schedule. So really, time to result is typical between 2 and 5 days, whereas if you're on an in-house lab, obviously you could get results much quicker without those shipping events and the test methods you choose. Cost is probably one of the biggest concerns when you're looking at third-party versus in-house. Third-party lab, I've heard anywhere from being charged $20 to $55 per test. Again, that would be without your overnight shipping, or some labs also have a courier system. That's pretty helpful if they can pick up and just drive to the lab. In-house labs, your costs, really looking at anywhere between $8 and $30 a test. And then regulatory. There are some things you want to consider. You want to, if you're choosing a third-party lab, make sure that they are certified, that it is a quality lab. You want to make sure that you're requesting they use OAC methods or validated methods, understanding that there are differences in some OAC methods, which is an association that approves Listeria methods for detection vendors. They're not all USDA approved, so it's somewhat easier to get an OAC certification on a Listeria test if you're selling one than it is to actually get one approved by the USDA. So if you're considering bringing in testing in-house, you want to make sure that you have some training, definitely training, and document that, and that you're following all the procedures that the vendors have put on that test, and you're following some good laboratory practices. So considering bringing testing in-house, this really goes towards this and can maybe give you an idea on why some third-party labs might charge you a little bit more based on different methods. There's equipment costs, and you can see the differences there. Similar with PCR immunoassays, similar with sample 6. So some upfront equipment costs to be able to do Listeria testing. Some methods require a little bit of additional equipment, so some heating blocks and incubators. You can see PCR immunoassays, a little bit more equipment needed, and then maintenance contracts. Depending on the PCR company, immunoassay company, and also sample 6, you might need to get maintenance contracts on the equipment that you purchase so that they continue to service that. And I'll go through cost, test, and consumable. So what you're looking at is an initial capital investment, and then followed up a routine testing cost. So what will you be spending on a routine basis for your tests? So obviously your kit costs would be included in there. Enrichment or media costs. So for those methods that require enrichment, you'll have to buy the enrichment media, grow the bacteria, and then use the kit associated with those methods to detect. So really the important thing here is your total cost per test at the bottom line, comparing those methods. And also, if you're considering bringing testing in-house, you'll want to know what it's going to take to produce a result. So here's some really key terms to pay attention to. Operator skill, PCR, immunoassay, because those require enrichments, a few extra steps. You want to make sure that the technicians doing those have some skills. So have seen a pipetter before and are used to transferring volumes and understand the concept of sterility. Sample 6, a little bit different, a little bit less operator skill required. Sample prep time, about the same for all methods. Hands-on time, pretty close to the same. Some are a little bit more tedious and require a little bit more work at the technician level. The incubation time, so we had gone through that. How long does it take before you can actually produce a result? And then how long does it take once you enrich the sample and you're ready to detect? How long does that detection take? And there are some differences between PCR, so between 3.5 hours or so, immunoassays an hour and a half, and then sample 6 is pretty quick, pretty instantaneous. So now what I'd like to do is pretty quickly is just to go through maybe a little bit more about sample 6 and how we've changed a little bit on how we do things, and really our goal is to bring the testing right to the plant. I won't take too much time on this. I think we've spent quite a bit of time here during this talk to give you some great ideas on what Listeria is, maybe some choices, third-party or in-house testing, and some concerns as you're trying to figure out what to do with your Listeria testing. And cost, I think, would be a big concern and a big factor as you make your decision. So sample 6, what we've developed is a test, a phage-based test that's rapid. And we also have software, and that's something we haven't talked about. And the software really helps you, it's environmental management software that helps you track your results on a floor plan in your plant. As I mentioned before, it's very important to have AOAC, which is a certifying body, and USDA. There are, again, some methods that are certified by AOAC that the USDA would not wish that you use in your plant. And regarding the software, this is one thing that we had noticed when we came to plants. How do you track that data? It's one thing to get all your results, but it's another thing to do something with results and take action on them to make your plant safer. So how do you track that, and how do you pay attention to that? Most people that we've seen use Excel spreadsheets, some lab notebooks. There are some LIMS systems, some laboratory information management systems or other software that people put their results in, and some people just don't know what to do. They get their results at the third-party lab and they stick them in a folder and they use them if they need them during an audit. So sample 6, again, a very fast test, 7 hours. What makes it different than everything else on the market is this no growth, enrichment free. So since we do not grow up Listeria in a lab or in your plant, it makes it safer to use. Obviously, it has to be as accurate, as I mentioned, that 1 CFU per sample. Bringing testing to a plant, it cannot be hard to use, so we had made it very easy. And because of all these things and testing and the flexibility of the way we process and produce our result, it is a very low-cost option. This is a pretty highly technical slide. I won't go into too much detail, but this does highlight really what's going on in a phage-based test. Here is our phage, very similar to a virus, or it is a virus. So you can see it does react with the surface of the Listeria cell. It uses the mechanics of a Listeria cell to produce its target, and then it actually detects that target. So the target detection for sample 6 is not the actual Listeria, but it's an enzyme that is produced by the Listeria cell during the process of our detection. When comparing different technologies and maybe how many shifts go by. So this is another way to look at a time to result and how that relates to your product and to the flow of your product in your plant and how that relates to shifts. So choosing an on-site in-plant test method like sample 6 that gives you results in 7 hours, you could actually get results for your Listeria testing in 1 shift compared to a PCR which would take between 4 and 8 shifts, and this is really just the amount of time these test methods take. So the concept here is what's happening during those shifts. You know, we'd have 4 or 5 shifts. Maybe Listeria was located in that first shift of samples, but you won't know that until multiple shifts of product are produced on that line. It really puts more of that product at risk potentially. A quick picture of our detection system and software. It comes with an iPad. As I mentioned, the software is really what's used to give that final detection. And one thing we haven't talked too much about is FSMA. So I thought I'd just give you a generic slide on FSMA and what that means and what are some of the things that FSMA cares about. And FSMA is really looking to increase your awareness of hazard analysis within these small and medium companies. So identify your hazards in your plant, establish some preventative controls to deal with those hazards that you've identified. And then once you've established those controls, you need to monitor to make sure that those hazardous areas, those hazardous points in your plant are being monitored so that nothing slips in. And if you do happen to find something in your plant, FSMA wants to know that you've got a way to deal with that, so corrective actions. And then to encompass everything, how do you know that the system you put in place is working? So verify your HACCP plan or verify your food safety plan. And that's with monitoring and that's with constant checks to make sure your system's working. This will be my real last slide. What we've done really at Sample 6 is tried to bring testing to where it hasn't been before, right there at the plant, to give you results within 1 shift so that the results you get are actionable. And you can really take action on the results you get within 1 shift and make some meaningful changes and meaningful decisions about the products in your plant. And then we also supply the software so that it gives you kind of a upfront look at some trends that might be happening in your plant. And I think that might be about it. So again, I appreciate your time here, and I know Trevor might want to say a closing word or two.
Thank you so much, Shawn. I actually have a few questions for you that have come through while we've been in session. The first one is, how does detection of Listeria species change culture with upper management? And in terms of how has Sample 6 seen a cultural change because of rapid detection?
Yeah, samples, well, first of all, let me answer your first question. How has Listeria kind of the culture shift at the top? I think, you know, at upper level management, what I've seen recently is really the word FSMA. I mean, I think the people at the top know now that they really do need to do something. Maybe they have been doing something, but maybe they know now that they need to do more. I've also seen a shift from really L mono testing, maybe in the last 10 years. People had wanted to do more L mono testing, and that was basically a business decision because obviously they would get less positives with L mono testing because it's a smaller group, and they were able to produce and release their products quicker. Now, as they looked more at environmental, they really made a shift towards Listeria species testing. And species testing, the way they do that is if they do get a positive, they act on that as if it is L mono. So they're really throwing a broader net in their plants now and cleaning up areas, like you had mentioned, Trevor, that may not be L mono positive, so that's the pathogen that's regulated. But if they did find Listeria species, there's conditions in that sample that most likely would grow and harbor L mono at the same time. So the risk analysis between L mono and species has changed, I think, at the top. And what sample 6 has done is put that together and provided the real-time testing, we call it real-time as there is right now, for Listeria species testing, so that they can make some changes, not big changes, but if you're getting results every day, you can really see things creep into your plant before they become a problem. And really the whole goal is to keep them from getting into your product. I hope that answered your question there, Trevor, or whoever posed that question.
I think so. All right, moving on. How do I know what test method is best for my plant?
Yeah, no, that's a really good question. You have to, all those things that I had brought up before are considerations. Cost, I think, is definitely going to be one of the major considerations, especially if you're increasing testing or if you're starting testing. I mean, these are new costs in a food safety system in your company. So, you want to make sure, obviously, if you're spending new money on food safety, you want to make sure that you're doing the right things. So I would say cost, I've seen, is really one of the major concerns. Another one is, how well does a particular test method work in your plant? I've seen, places where people are using an ELISA method, for example. ELISA methods are a little bit less accurate in some cases, where they can detect things that are not Listeria. So it could be working great in one of your plants, but you tried the same test method in a plant down the street. You might just happen to have some of those bacteria in that plant in a niche that would cause that test method to become positive more often than not. So in those cases, you'd be looking at, well, this test method, ELISA method maybe, gives us false positives. You just happen to have some of those bugs that give that test method false positive. Now, that's not saying that in general that test method won't work for you, but maybe not in that plant. Those are just some examples. It's really quite complicated in trying to figure it out, what test method to use. Really establishing what you want to spend might be a good start. And then how do you accomplish that? Look at the different third-party labs. I would shop around, maybe one or two, and get some quotes from them. Just like any other business, competition is great to keep costs down. So hopefully, those are some things. But as far as deciding what's best for you, it really is, the way your product flows, and also the risk of the products that you produce can also be a factor. So the higher risk product, maybe your shelf life on your product is 2-3 days. So you're going to want to use one of these tests that give you a quicker result. Because if you use a test that takes 4 days on a product with shelf life for 3-4 days, you really just take the sample and throw the product away, because you won't get results before you get your product is ready to go out the door.
Great,
so
thanks, Shawn.
You're welcome.
Here's another question that came through. Are there any lab certification classes in the market? We see everything from food safety certification or specific audit scheme classes, but is there any classes out there that you could direct somebody into kind of gaining more knowledge or an intro to lab?
Yeah, there are some classes as far as how to choose a lab or how to set up a lab. Maybe not classes. I can give you some ideas on how to become certified. The big third-party labs and some very large food labs, where this is a corporate lab within a food company. This is typical for some who send all their testing to their own corporate food lab. But there is a certifying body. It's an ISO certification. So it's a ISO 17025. is the typical certification for a food safety testing lab. It can also be referred to as A2LA, American Association of Laboratory. I might have gotten that wrong, but A2LA is a similar category. Now, there are some courses out there that are taught by, I know there is one actually service lab, third-party lab, Cherney Labs. They're starting to offer some training to companies, actually to everybody, to companies, to diagnostic vendors, and they customize their training really to what you need. So I know them very well. I would refer to Cherney Labs, definitely for one. There are other labs who certify your lab and also your HACCP plans. Silica has some programs. Diable Labs has some programs. Really, if you'd like to talk about individual labs and what they could offer, definitely give me a call and I can go through that with you. There's also some universities who have programs, really food safety knowledgeable programs. Penn State has got a good one. Texas A&M, they have a good one there. There used to be a good one in Colorado, but that one's gone now. So there's definitely resources out there, and I can point you in the right direction depending on what you're interested in learning or becoming certified.
Great, thank you. The next question is for Control Point. How can Control Point help make a cultural impact? It's a very good question. I think it's a case-by-case scenario for each customer that we're working for. It depends on what they're set out to achieve and how we're going to achieve that together. But a lot of times we go into a classroom setting and sit down and we assess what the current knowledge is of food safety for the entire plant. And it doesn't mean one by one, especially if we're doing a plant of 1,000, but it starts more at the upper management level and then kind of trickles down. And then we try to spend time to interact with the plant personnel to really gauge on what the culture is at the time, and then obviously we go back and work with upper management to implement that. But it's really a case-by-case scenario. It depends on what you're set out to achieve. Sometimes we go into certain plants and they're not concerned with their culture, and it's not even a topic of discussion. They've already developed a strong culture from the beginning or have worked towards developing it in their current state.
Trevor, I have a comment on culture. I might have missed this. As you were talking, it brought to my mind, but I can give you real-world example on how I've seen culture grow really within 1 or 2 days. The way we do things, or we've done things in the past with Sample 6, is we'll come right to the plant. So we bring 2 people, we bring some equipment, we set it up in a room, and the first thing we do is we engage with, obviously we've discussed this with upper management, and now we're right there in the room. The first thing we do is we go there on the plant and we take samples with the current QA. So what ends up happening is, we're the most famous people in the plant at that time, because all the people all the employees start really looking at what we're doing. We're walking around with sponges and we're crawling under things and we're taking samples. So it really piques the interest. It really starts that within these 2 days that we're there. It starts that food safety, path. It's kind of building momentum. And so as we're there for 2-3 days, we start to get to know. We end up taking samples 2-3 times. We walk around with QA managers, and we have the QA managers, tell the people on the line, hey, this is what we're doing. We're looking for Listeria. It doesn't affect your job. We're really trying hard. We try to get them to engage, and even suggest that maybe you should have this person just go out and look for Listeria. So have new people take samples so that they see that this isn't something to be scared of. And we've also seen, as this goes throughout a day or two, we really see, now instead of we're trying not to find it, you get to the point where everybody in the plant is, we know it's there, we just want to find it. And so sometimes these management groups will establish rewards, if you can go find Listeria, or they give them, don't have these defined locations, just go out in the plant anywhere we haven't tested before and just see if you can hunt and find it. So I think that goes, pretty well along with how do we see the culture changing in food safety. And it's been pretty fun and exciting for me to see that happen, like I said, in a day and a half or 2 days within one small plant, and really engaging, different levels and different groups, from the person on the line producing the food to sanitation, plant manager, QA. Really everybody gets engaged when we do these on-site 2-day visits.
That's great. So in other terms, you're empowering those that are not necessarily part of the food safety team. Sometimes they are, sometimes they aren't, but you're empowering the people to have a voice in a way without them actually having to say anything. And that's where we see a huge cultural change, is when you give your staff, your team, your co-stars, employees, whatever you refer to them as, you're empowering them to have that voice, to do the right thing, and to speak up, and for them to understand that there's not a negative implication for what they have to say or what they find. So that's fantastic.
Yep, but I will say it does come from the top. It's very helpful to have the buy-in from upper management, and have them, like you said, start that culture and be part of that culture. It's difficult, more difficult, and it happens a lot to start at the bottom and bring the culture up. I just thought I'd...
Absolutely. Just like food safety, culture is do what you say and say what you do.
Correct.
I think we have one more question here. Let me see. We talked about benefits of building a lab on site, possibly in a separate building, so we've already answered that. And we answered all the questions, so that was it.
Good.
Well, Shawn, thank you for coming out and co-hosting this webinar with me. It's been an absolute pleasure. It's been very enjoyable. And thank you to all the attendees. As a thank you, we're offering 10% off for our services at controlpoint.consulting, which is our website. There is no .com. Now that can be kind of confusing. And just mention the code FoodWeb1, and we'll offer 10% off. We do HACCP certification or ServSafe certification, which is more food service retail level, very big in the state of Nevada. And we're working on our SQF consulting application. So hopefully we'll have that in and approved in no time. Well, that wraps us up for today. Shawn, do you have anything else to add?
Nope, I just want to, as you did, thank you, Trevor, for inviting me and working on the webinar with me, and I had a good time talking to everybody here. And again, if you want to reach out, I know I brushed on a lot of topics on the surface, but please let me know if you have any questions at all on any of the topics we discussed, or you're looking for industry trends or anything like that. Feel free to reach out to me. I believe you'll have my contact information as well through this webinar. So again, thanks again, and appreciate the time.
Thanks, Shawn. Everyone, have a wonderful weekend, and hope to hear from you soon.